Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Rocket Monday, we're going to talk about New Horizons probe. So let's dive right into it. Well, you have to understand NASA has multiple categories of program. Each program falls in a certain category, and by that metric, it's decided allotted a certain amount of budget. So NASA have their flagship missions, which would be like Hubble, James Webb Space Telescope, International Space Station. This will be classified as what we call flagship. Basically, get it done no matter how much it costs. Now below that there is a tier which is mid-budget projects, which we are talking about here right now, new frontier programs. So basically the first mission of this catalog is this New Horizon system, and the whole goal of a new frontier program, this whole sector is specifically built for researching solar systems. So it's not going to focus on extra terrestrial things, basically like other exoplanets and all that jazz. It's only focused on solar system. Every mission has to improve the knowledge of our own solar system, not focusing on something else. So this is the whole point, and their main target was, we have studied Jupiter, Saturn, Uranus and Neptune, but we had not studied Pluto. So they wanted to extend that data point, and it was launched on September 24, 2005. So it's kind of old at this point in time, and they launched it on top of Atlas V rocket with extra booster, because this was launched on a very quote unquote crazy speed trajectory. Basically it did not orbit Earth. It's just like they launched it directly. It was kind of amazing that they did it, and that's why the probe also had certain limitation. Basically they wanted to make it as small and light as possible, so they can dump as much velocity right off the bat. Like they did not went like, okay, I'm gonna orbit and then I'm gonna increase the speed. Direct one go. So this was the whole overview of the project. Then what was the goal? Like, okay, they made it, what they're supposed to get out of it. The idea was they wanted to study Pluto systems, plutonium system. Now when you think about planet, you just think about planets, but in Pluto's case, Pluto had a kind of a rocky history, simply because even though we detected it very early on, from day one it was like, it's a bit too odd. Like it did not make sense simply because of the distance it was, and early days, as in like 1950s, we could not understand the size and mass and all that jazz. So very early on we realized there's something else on there, and with the advent of Hubble telescope and other high resolution telescopes, we figured out there is a whole lot of things there. Like a whole lot of things are there, including multiple moon systems. Now the reason why Pluto is not classified as a planet is simply because it's an incomplete planet, so to say. It would have become a planet if it was inside a dust cloud. Basically dust cloud would have fallen onto it, and it would have become bigger in the size, but it failed to do that. And to be a planet, you have to have basically control over your own orbit, aka let's say Earth is spinning. Now you might be asked, where is the axis of that Earth spin? It is inside Earth. Basically Earth is spinning on its own axis. Pluto is not doing that. That's why Pluto and Mercury, even though they are quote unquote roughly of the similar size, they have different classification, because Pluto literally, like if you see Pluto and it's like, okay, it's spinning outside, like it's following a point in space. Why? Because the moon it has, quote unquote, because in the early days we discovered moon, it's so big, it's so gravitationally powerful, it literally pulls the center of gravity basically of these two combined body as a binary system outside of Pluto. It's not like, okay, moon is orbiting Earth. It would be like Earth is orbiting somewhere ahead of its surface. So it's like going like this rather than spinning. It will be orbiting a point. That's why it's not dominant on its own orbit. That is the core reason why it's not classified as a planet. While Mercury, even though it's small, it's a rocky planet, aka basically all current data is like, this is the core of a planet itself, so it's ludicrously dense for its size. And this puppy, while it is a quote unquote rocky body, it's a more of an icy body, so it does not have the oomph, the density that it needs, and on top of that is smaller than our moon. So this whole once we actually started to study this, we realized the Kuiper belt reality, because once you cross rocky bodies, basically Mercury, Venus, Earth, Mars, the moment you go to Jupiter, before Jupiter you will have a band, the band is known as asteroid belt. There is a lot of rocky bodies left. Now we thought that's it, that's where all the small rocks are there that are not claimed by any planets. But the moment you start to go further out, basically you went from Jupiter, Saturn, Uranus and Neptune, the moment you cross Pluto, you realize there is a whole belt known as Kuiper belt. Now this belt is ludicrously sparse and ludicrously dim. We cannot detect it with using normal telescope. Even Hubble telescope will have hard time detecting anything tangible in that. Like again, Pluto is kind of big in this, that's why we discovered Pluto so early on, but everything else in this belt is so dim, you have to study them from space, otherwise you will flat out not say. And given the fact the objects there are not very small, like they are not what you call they are small moons, they are smaller than smaller moon, but if any one of them falls to Earth, yeah, it's gonna annihilate Earth. So we had to study this. And this is what we call leftover. Basically, whenever a star ignites, they have a accretion disk. Now, in that disk, planets are formed, but this disk somehow survived. Basically, it did not fall into a planet. And if Pluto had any more gravity, or let's say these two moon collapse, solarly over time they will make it into a planet. That's why this is not classified as a complete planet. It's just a planet seed. So we have to study this body in order to understand how far it stretches, because you have to understand the density is so low that Voyager just went through it without understanding it. So this mission was fine-tuned for that, like study this exact area. And because of the fact that it's untouched by any big gravitational event that is happening inside, it's early solar system's history. Basically, the history there is preserved. So we want to study this. That are the goal for that. It's not just Pluto done. It's a study of the whole ecosystem that is there. Now, what about power and propulsion? Again, this will be the third mission I'm talking about. Solar panels simply would not work. They utilize radioisotopic thermoelectric generator. Now, because of the fine-tuned range of this puppy, this was kind of small in terms of, generally they put 3 RTGs. There they put only 2 RTGs, and it was, the power was lower than Voyager's system. It was 245 watts. Again, advanced in computer chips and all that has also made it much more efficient with the power. And it was did not have any gimbals. You have to understand that Voyager was designed in such a way that its antenna will be facing Earth, but its camera unit can focus independently. So it, like, antenna is directly talking here, but camera can like literally look wherever it needs to. In this puppy, because they wanted it to go so fast, they had to make it light. The only way to make it light, basically they mounted everything, the camera, the sensors and all that, they are body mounted. They cannot move or rotate or anything like that. So the whole body has to move in order to point a camera. Benefit, lightweight. Side effect, you have to have 8 thrusters. This has 16 thrusters, 4 of them are main thrusters and 12 fine control thrusters, which 6 of them are redundant. But the moment it did the what we call Pluto flyby, it had the issue, simply because if it's gonna aim itself so the camera faces Pluto, the dish will no longer face Earth and communication will be broken. That was the known trade-off that they did to make it light enough and fast enough so it can actually do the mission. And not to mention, the flat of the target was like 10 years, 10 years, like launch it today, 10 years after. So they wanted to make sure the equipment will keep working reliably. So how do you make something reliable? Make it solid state, does not have a moving part. That's why it was very successful. Hydrogen monopropellant was used. I think that was like the primary choice of almost everything back in the day. But it was spin stabilized, because the way the body was built, there was no things, moving parts. They did not had anything that would counterbalance the center of object. So they had to spin it so the antenna can directly face Earth reliably. That is why small thrusters are used. Basically, they have 4 main thrusters, which are like big things that will aim the trajectory, and then have 12 fine one, in which of them 6 would be like firing to just keep it spinning, and they will slow it down once it starts to reach Pluto. So that is the way they can achieve such a ludicrous speed during launch time. Now, this is such a tricky part simply because the lag is 4 hours, aka at light speed it's 4 light hours ahead. At this point in time, Voyager is 19 light hours away from Earth. This puppy is 4, and it reached there very fast without too many gravitational assist. So it's kind of traveling faster, but again, it's the trajectory is very straight. It's like just go. In terms of Voyager, the trajectory is like tuk 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 tuk. It's going all around the solar system, but this had trajectory directly go outside. That's why it's at Pluto so early on. So the flyby happened. Now, why the heck they did not try to basically orbit or do something like that? Reality is Pluto is too small. It did not had enough gravity. So consequence of that was like either they had to ascend it very slowly, so they had to remove little bit speed when they launched them, which flat out was unfeasible, simply because that would have translated to, yeah, you started this mission 40 years from now, it will actually reach there. People are like, no, that's unacceptable. So they are like, okay, design as fast as we can go, but because our instruments are so fast, like we are talking about like satellites, telescopes and all that, it's really fast nowadays. Like our CCDs, CMOS sensors, spectral graph, those can like 1 second, boom, done, all the data collected. So the choice was made, it will not even try to do basically orbit, because the gravity is not strong enough. You have to have a like freaking Atlas 5 firing backwards full force just to slow it down. That was infeasible. The probe was way too fast for that. So side effect of that, it only had few hours. Basically, it will see the Pluto once it's inside the instrument range, because again, you can see Pluto from Earth. That's how we discovered it. But instrument range, basically the fine-tuned instrument that they had, it had only few hours of workable distance. Basically, like, yeah, I'm giving you high resolution data which you cannot get from other space-based telescopes, including Hubble, because Hubble could only see this as bright spot. Like you will see some diagrams where they will show Hubble is showing yellow tint. That was computer calculated. Again, accurate, but computer calculated. It was not just, it was just a blob. So to get actual data where you can like, okay, this is how the planet is, this is how the nitrogen ice is flowing, this is how the glaciers are, they had to have a very fine telescopes. Those telescopes only had few minutes to actually do the data collection. And at the closest point, where it's like closest, like just making as close as possible, it was 12,500 kilometers from Pluto. To give you a context of that, that distance is so close that our geostationary orbit is higher than that. Our geostationary orbit is 36,000 kilometers. So this puppy was much closer than that. Like think of it that way. Like it's basically a satellite. It just did so quickly, and that was done July 14, 2015. So it achieved its mission, and the amount of information it got out of the basically Pluto system was amazing. But the reality is like right now there's a serious speculation this might also has undersea, basically undersurface sea. Almost everything turns out has undersea, and this became the first probe to capture video of a volcano when it was crossing Jupiter. So that's the most amazing part, like actual video. Again, it's only few frames, but you get the idea, like actual volcano footage is there. So what was the future after? Like again, so like we sent it for 10 years and it just did a flyby. Then what after that? But because of the distance, because of the 4-hour light lag it has, the reality was the data bandwidth that is coming back was less than 1 kilobit per second. So it would take, like capture gigabytes of data, but it will take months to download that data, to basically upload data to Earth. So they had like reality is like, yeah, we captured the data, but we have to wait in order to do anything. During that time, before even the flyby was done, they realized they are going into Kuiper Belt. They know there are more things. What if we could find something that is directly behind Pluto? It does have thrusters, it does have RTG, so it is not running low on power, it is not running low on fuel. So what if we can have, let's say Pluto is here, something is here, what if we try to study that? So a whole task force was established where like find something behind Pluto, and they failed again, and they failed again. Then they're like, okay, use Hubble to find something. They found something, and then the problem was they could not know the size or orbit or anything like that. They find something directly behind it, then they try to find occlusion. Occlusion simply means a star is there, known brightness, and this object will cross it. They tried that 2-3 times, failed, and fourth time they figured it out, like, okay, this is the orbit accuracy was predicted with very high enough accuracy, where it's like, okay, this is how the object is. They had multiple amateur grade telescopes lined around, and using that data from all that, they figured out like what is the size of that. Like they originally came up with this data, it's like this is the most possible estimation of the reality, and based on this data they calculated like where the probe is, how the heck the probe has to go. This was done few months before the orbit flyby. So basically this was done as quickly as possible. They did not even knew like this object was like Ultima Thule, just it was named. So they went through this, and this is the furthest object ever studied by human. Furthest object, flat out, like not in terms of like, okay, there is a planet somewhere else. No, this is a probe going there, actually seeing that. And you have to understand that like we came very damn close, but reality is this also has, the axis is literally in the center. The small boy actually has bigger mass, and the fat boy it's basically fat. It's like a pizza. One is like a ball, another is like a pizza. So the spin axis was kind of throwing us off. But it was quite successful. We actually studied this, and because it's the surface is kind of fresh, it's not getting bombarded by other asteroids, so it's fresh. That's why we wanted to call this study this. Kuiper Belt is completely quote unquote intact, so studying these helped us learn a lot. So this was just an overview of this massive project. I have provided the NASA link down below and a documentary. I hope you like those things also. And if you like this video, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I'd urge you to press dislike, press it twice to show me an extra disappointment, and please leave a comment because I try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.